What's up everybody, it's TEKTHRILL, back again with another video. Today we're diving into AI and plasma computing. Plasma computing promises crazy fast processing speeds and energy efficiency that could revolutionize everything from AI to scientific research. But as with any bleeding-edge tech, there have been some, let's just say, learning experiences along the way. We're talking about the fails, the hiccups, the moments where plasma computing didn't quite live up to the hype. So, buckle up, because we're about to dissect some of the most notable failures in the world of AI and plasma computing. We'll analyze what went wrong, why it matters, and what lessons we can learn from these setbacks.
All right, let's kick things off with one of the biggest headaches in plasma computing: instability. Plasma is often called the fourth state of matter, superheated gas where atoms break down into charged particles, ions and electrons. This unique soup of charged particles is what makes plasma so interesting for computing. In theory, we could manipulate these particles to perform calculations at lightning-fast speeds. The problem is, plasma is full of energy and can be super unpredictable. One minute it's behaving, the next minute it's creating turbulence and chaos. Researchers have been working on ways to tame this wild child, using things like magnetic fields and lasers to try and confine and control the plasma. But it's an ongoing battle, and until we can get this instability under control, plasma computing will remain a bit of a gamble.
Okay, so let's say we somehow manage to wrangle that unruly plasma. Even if we can get the plasma to play nice, we run into another major roadblock: hardware. Current computing hardware just isn't built for the extreme environment of plasma computing. We're talking about temperatures hotter than the surface of the sun. The materials we typically use in electronics would basically melt or vaporize under those conditions. Plasma also emits a ton of radiation, which can fry circuits faster than you can say system crash. Researchers are experimenting with new materials and designs, but finding something that can handle the extreme conditions of plasma computing is a massive engineering challenge. It's like trying to build a spaceship out of popsicle sticks. You need some seriously next-level materials science to make it work.
Chapter 3. Software bugs when code meets chaos. Let's shift gears from the physical challenges to the digital realm, because even if we solve the hardware hurdles, we still need software that can actually talk to this plasma beast. Coding for plasma computing is not your average walk in the park.